Hello everyone, this is Amika Mahajan. Welcome to my channel. In this video, I'm going to discuss more questions from NCERT exercise. Chapter 1 of NCERT, unit is Electrostatics and class is 12. Let's understand the statement. Explain the meaning of the statement. Electric charge of a body is quantized. Why can one ignore quantization of electric charge when dealing with macroscopic? That means large scale charges. So, first of all, what do you mean by electric charge of a body is quantized? It means that the charge on a body is integral multiple of the charge on electron, where n is integer, is electronic charge. Why it is so? Because integral number of electrons can be transferred from one body to another on rubbing. So what will be answer for meaning of charge is quantized? That means the charge on a body is integral multiple of the charge on electron. Now we have to tell at macroscopic level we can ignore this quantization. Why it is so? Because we deal with charges of a few microcoulomb at macroscopic level. When I take 1 microcoulomb charge and calculate n from the formula Q equal to Ne, by putting the value of charge 1 microcoulomb and electronic charge 1.6 into 10 raised power minus 19, I get this number 10 raised power 13, very large number. That means grainy nature of charge is lost and charge appears to be continuous. That is why we can ignore quantization of electric charge when we deal with macroscopic or large scale charges. Now come to next question. It is 1.5th question of NCERT, chapter 1. When a glass rod is rubbed with the silk cloth, charges appear on both. Now you have to tell. Same thing is observed with many other pairs of bodies also. Explain how this observation is consistent with law of conservation of charge. When two bodies are rubbed, then what happens? Transfer of electrons takes place from one body to another. And only integral number of electrons can be transferred. One body has atoms having tendency to lose electron. Other body has atoms having tendency to gain electrons. Suppose these two bodies are being rubbed. Initially, because everything is made up of atom and atoms are neutral, so charge on this one body is 0, charge on second body is also 0. So total charge of the system is 0. But when these two bodies are rubbed against each other, suppose this first body loses 5 electrons, then charge on first body will be new charge. It will be plus 5e, deficiency of 5 electron is there. And charge on second body will be new charge. It will gain 5 electrons, so it will be minus 5e charge. So this is example which I was taking. I can take it in general form also. Suppose the n number of electrons are transferred from one body to another, then charge on one body will be plus Ne and charge on second body will be minus Ne. When I take sum of both the charges, again it comes out to be 0. That means charge can neither be created nor be destroyed. So when two bodies are rubbed, equal and opposite charges appear in both the bodies, as a result of which this observation is consistent with law of conservation of charge. Now come to next question. This is the 11th question of first chapter. A polythene piece rubbed with wool is found to have negative charge 3 into 10 raised power minus 7 coulomb. Estimate the number of electron transferred from which to which. And is there a transfer of mass from wool to polythene? Because charge on polythene is minus 3 into 10 raised power minus 7 coulomb. That means more charges on polythene. So charges are transferred to polythene from wool when these are rubbed by transferring electrons. So we can also calculate how many numbers of electrons are transferred from wool to polythene by taking the formula Q equal to Ne. This comes from quantization of charge. So N is Q upon E because integral number of electrons can be transferred. So N will be integer. Now charge Q is given to me. It is 3 into 10 to the power minus 7. I will put the magnitude. Electronic charge is 1.6 into 10 to the power minus 19. I will put magnitude. So by taking this ratio, I can calculate the number of electrons transferred from wool to polythene. Because each electron carries mass. Mass of one electron is 9.1 into 10 to the power minus 31 kg. So when electrons are transferred from one body to another, mass gets transferred. So the body which loses electron will be having less mass, and the body which gains electrons will be having more mass. How much mass will be lost? If n number of electrons are transferred from one body to another, then first body will lose n times mass of electron. Another body will gain n times mass of electron. So one body loses mass, another body gains mass. So there will be transfer of mass when electrons are transferred from wool to polythene. Thanks for watching this video. Like, share, subscribe my channel.